Good morning, boys and girls, and welcome back to the southern wing of the Stink Bug Works, where I have a full cup of coffee, and it's hot. So I'm going to share with you folks as I talk about today's topic. Today's topic is I have the shaft for the gearbox and some nice smooth bearings, by the way. Nice smooth bearings. And I am going to make the motor mount. And so here's why I like having a DRO on my mill. So here's the plan. I'm going to take this 2mm carbon fiber and cut out a square a little bit bigger than that with a hacksaw. And then I'll put this flat surface down in the mill. And then I'll mill the top. And then once I have the top, then I can put some parallels in the vise, chuck it up, and then cut one edge, flip it over, cut the other edge, and have a nice square piece that I can use some rubber cement and glue this little full-size template on. So this full-size template is the motor mount. And, you know, I could hook up the rotary table and go through all the business to cut this one smile cut, but that's just like 3 hours of setup work for a 10-minute cut. So what I'm going to do is, I'll talk about how I'm going to do it, but I'm going to drill 3 holes and then I'll just connect them using a file. So what I did is, I drew it up in AutoCAD. I made my measurements here and so forth. And so I left room so I can go to a couple of different pinions. I can go a couple teeth larger and a couple teeth smaller. So I'll have some flexibility in gearing if I find a prop that works particularly good, but I want to spin it just a little bit faster, or a bigger prop that needs to turn a little slower. So here's the deal about DRO. Here's a blow up of this thing. So I'm going to go in and I'm going to chuck this thing up or clamp it up in my mill. And I'll have this template laid out and I'll hover the tool right over this hole and I'll set that at 0, 0. Where that hole falls in the whole thing isn't as critical as I have it about there, because everything else will relate to it. So then I'll zero out the DRO, and then I can just go to these coordinates here and drill these holes. And because carbon fiber likes to splinter, what I'm going to do is I'm going to go in with those really small little mills that you see in routers. In fact, using these E8 collets, these little tiny mills. So I'm going to go in here and first drill everything with a pilot. And then, because it's all on coordinate basis, I can come back to 0, enlarge this hole to whatever this is. I think it's 3 millimeters. Come in here with 3 millimeters, 3 millimeters. I'll leave that one a little small, and then I can just connect them all. And this was 10 millimeters, so I'll eventually go in with a 10 millimeter reamer. I'll keep upsizing the bits until I get to a 10 millimeter reamer. But the 10 millimeter reamer and the little itty bitty thing are both going to be at those coordinates. So I'll have a perfectly laid out set of holes, and then I can just file and shape, the whole thing. I need this area low right here because these bolts are a little bit off the surface of this clamp, and I'd like this clamp because of where the water jacket has to fit. You notice I shortened the water jacket. It used to have a black stripe in, so the water jacket's a little shorter now. So that's how they're going to go. They're going to go just like that, with this plate in between them. And this will allow some swing, and this will get glued to the shaft. And then finally, looking down from the top, out of this same carbon fiber, I'm going to have like a T. It'll have area for this to bolt down to, so it'll be kind of like this part of a T and that part of a T, and that part of a T will include this, so that I will be able to bolt it down to the hull, and that way I'll have a good solid attachment. So there's the planning. I may take you over to the mill today when I do this, and you can watch the first few little small diameter holes going in. That might be kind of fun. So until then, or until next time, jet out.